So in this video, we are going to talk about multiplying and dividing expressions with common bases. So basically, we're going to talk about exponents. So just a real quick review of exponents. It's used to show repeated multiplication of a base. So here's your definition. Let b represent any real number and n represent a positive integer. So that means b to the n power. The base b gets multiplied out as many times as you need to match the exponent. Also, you need to remember that when you do not see a visible base, a visible exponent, it is implied that the exponent is 1. And here's your example. If you just see x, the exponent is understood to be a 1. So in examples 1 through 3, we are going to talk about the difference between the base and the exponent. So in example 1, we have a base of f and an exponent of 5. In example 2, we have a base of -3 and an exponent of 2. And in example 3, we have a base of g, and since there's no visible exponent, we have an exponent of 1. Now, I know I'm kind of getting ahead of myself here, but I do want to talk about, just for a brief moment, if you have an exponent that is a 0. So if you were to have y to the 0 power, that is always a 1. Now we will go over that again in a different lesson, but I just wanted to kind of bring that up, just to kind of refresh your memory about 0 exponent. So in example 4, it says, what is the exponent for the factor of 3 in the expression? Well, this is 3 to the first power times c to the 8th power. So the exponent for the factor of 3 is a 1 because there are no parentheses. Now, if that had been 3c to the 8th in a group, then the exponent for a 3 would be 8. Okay, so without parentheses or with parentheses, you have to pay attention to that. That's very important. So we're going to write the expression in using exponents for 5 through 7. So across number 5, we have -3. We have 4 m's, so that would be m to the 4th. In number 6, we're going to keep the group around 5a, and there are 3 of those groups. And in number 7, across the top, we have 2x to the 3rd because there are 3 x's. And you can even group groups together. So since there are 2 y plus 3's, the exponent on the y plus 3 would be a 2. Now make sure you keep the group with it, because if not, it just makes it look like y plus 3 squared, that the exponent only goes to the 3 and not the whole collected group. So please make sure you pay attention to that as well. Now, evaluating expressions with exponents, there are 2 scenarios. And in both examples 8 and 9, it gives you both of those scenarios. In both examples, you see one set of things with parentheses and the other one without parentheses, and it produces 2 totally different answers. So in number 8, you see the group. The parentheses, when I say group, I'm talking about that parentheses, has the exponent 2. So that means you're going to take -4, the parentheses, and multiply it by itself twice, which produces a positive 16. Now in the second scenario, this is -1 times 4 squared, which would be -1 times 4 times 4, which would be -16. It produces a totally different answer. So please pay attention to whether that exponent is attached to a grouping symbol or it is not. So in number 9, we have a group. So we are going to take 1/2 times 1/2 times 1/2. The whole group gets multiplied by itself. So we get 1/8. 2 times 2 is 4, times 2 is 8. Here, I have 1/2 times 2 times 2, which is 1/8. Now, the way I worked it was different because of the grouping symbols. Although we came up with the same answer, it is a little bit different because of the way it is set up. All right, so in the next set of examples, it asks us to evaluate the expression. So we actually want to work it all the way out. So 22 to the first power just stays 22 because there's only one 22. In number 11, we've got -1 to the 50th power. That means there are 50 negatives. Now, if you're multiplying an even number of negatives together, it becomes a positive. If this were -1 to the 49th power, it would stay -1. So when you have a -1 in a group like this, that's what happens. Now, I am going to kind of show you what happens without the group. If you had -1 to the 50th power, that would be -1 times 1 to the 50th power, and that would stay -1. So please be very, very careful with those parentheses and when you don't have parentheses. So in example number 12, notice that the negative is not included in the parentheses, so you should be thinking -1 times 2 over 3 times 2 over 3 times 2 over 3, which gives me -8 over 27. I cannot reduce that, so I just kind of leave it there. And that would be my final answer. All right. In the next set of examples, we're going to use order of operations to work with our exponents. So please excuse my dear Aunt Sally if that's the way you remembered it. So the first thing we need to do is handle the exponent. So -1 in a group raised to the 5th power becomes or stays -1. So I end up with -2 times -1, and then I multiply and I get +2. Here I take care of both exponents. So 3 squared is 9, and 4 squared, or 4 to the 3rd power, I apologize, is 64. When you add those together, you get a grand total of 73. Now we have a lot of stuff going on in number 15, but first we have to deal with the exponents. So 2 to the 3rd becomes an 8, and 3 squared becomes a 9. Remember, you multiply before you subtract. So 24 minus 36, and that gives me -12. In 16 through 19, when it says evaluate, they typically give you a value for the variables in your problem. You substitute, and then you apply the order of operations. So we're going to substitute first, and then we're going to perform the order of operations, which is, please excuse my dear Aunt Sally. So the first thing I will do is I will replace x with -3. So -3 times -3 to the 3rd power. Then I have to take care of the exponent. So -3 to the 3rd power becomes -27. And when you multiply that together, you get 81. In the second example, number 17, I'm going to plug in -4 for y, or +4 for y, I apologize. According to the order of operations, I do what's in the parentheses first, so that would be -20 raised to the 2nd power, which would become +400. So be very careful with that because everything was in the group, and the group had the exponent. So in example number 18, we are going to plug in -3 everywhere there's an x. We're going to replace every y, substitute 4 in for every y, and then we're going to perform the order of operations. So I have -3 squared minus -3 times 4 plus 4 squared. So according to order of operations, we do exponents first. So that would be +9 minus -3 times 4 plus 16. Then I'm going to do all the multiplications. So I get 9 plus 12 plus 16. And when you add straight across, you get a grand total of 37. Number 19, We're going to substitute negative 3n and positive 4n. I'm going to simplify that to negative 7, and then I'm going to raise negative 7 to the third power. So 3 negatives produce a negative outcome. Now, multiplying and dividing with common bases. When you multiply expressions with like bases, you're going to add the exponents. When you divide exponents with like bases, you will subtract the exponents, okay? It does not matter what the base is. It can be a number, it can be a variable, but the rule applies. So like in example 20, we're going to simplify the expression. So if you see that as x to the third times x to the fifth, you should be thinking, you don't always have to write this down, but you should be thinking x to the 3 plus 5 power, which would give me x to the 8th power. The second example, like I said earlier, it doesn't matter if your base is a variable or a number. Since both of my bases are a 3, I keep the 3 and I add my exponents. So I get 3 to the 8th power. Now, sometimes they want you to simplify that out, and sometimes they simply want you to leave it as 3 to the 8th. So make sure you are paying attention to how they want the answer formatted. So in number 22, all of my bases are an A. So I should have 3 plus 1 plus 5. Now remember, the one in the middle doesn't have a visible exponent, so that it is understood to be a 1. When you add all that up, you get a to the 9th power for a final answer for number 22. Now when we divide, we are going to subtract. So what we are going to do, since in number 23, since I have g to the 5th divided by g to the 3rd, I'm going to keep the g and I'm going to take the top exponent and subtract the bottom one from it. So that gives me g squared for number 23. Same thing for number 24. I've got 4 to the 3rd divided by 4. So I should be thinking 3 minus 1, and that gives me 4 squared. Number 25 combines both of the properties. So the first thing I'm going to do is the numerator. And so I should be thinking 3 plus 6 over y to the 4th. And that gives me y to the 9th divided by y to the 4th. Now I'm going to use my division property. I use my multiplication property first. I apologize for not saying that. And now I'm going to do my division property, which means I will subtract. So y to the 9 minus 4 gives me a final answer of y to the 5th. Now, going a little bit further and simplifying expressions with exponents, we're going to use the commutative associative properties and some properties of exponents to simplify. So in number 26, we are straight up multiplying one term times a second term. So what we will do is I'm going to write down your thought process. This is what you should be thinking. You should be thinking, I need to multiply negative 2 times 6. I need to multiply c squared times c to the 3rd, and I need to multiply d to the 3rd times d. Now notice in the original problem, there is no addition or subtraction. I do have a negative 2, but that's not subtracting 2 from anything. That just means the 2 is negative. So now I'm going to apply everything I know. Well, I know that negative 2 times 6 produces negative 12. I need to add the exponents. So 2 plus 3 gives me c to the 5th. And I need to add the exponents. Do not forget there's an understood 1. So I end up with d to the 4th. And that would be your final answer for number 26. Number 27, the same way. I'm going to write down what you should be thinking. You should be thinking 3 times negative 4 times 1. There's an understood 1 in front of that r. And then you should be thinking r to the 5th times r squared times r to the 1st power. So when you multiply 3 times negative 4 times 1, you get negative 12 again. When you add up all those exponents, 5 plus 2 plus 1, you get r to the 8th. Final answer for number 27. For numbers 28 and 29, if you notice, we are doing the division property. So I'm going to, in number 28, since I have a to the third times a to the 11th on the top, and I have an a times an a on the bottom, I'm going to apply the multiplication property. So I'm going to be thinking a to the 3 plus 11 over a to the 4 plus 5. That gives me a to the 14th divided by a to the 9th. Now I should be thinking a to the 14 minus 9, apply the division rule, and I end up with a to the 5th power as a final answer. In the last example for this particular lesson, we are going to take 15 and divide it by 3. I'm going to take m to the 5th and divide it by m to the 4th. And I'm going to take n to the 12th and divide it by n to the 7th. 15 divided by 3 reduces to 5. I subtract my exponents. 5 minus 4 is an understood 1. And then in the last one, 12 minus 7 gives me 5. So the exponent on that n is 5,